We'll now look at some linear inequalities. And inequalities are very, very similar to equations. The only difference is instead of an equal sign, we have a less than, a greater than, a less than or equal to, or a greater than or equal to. And solving is very simple. So if I have something like A is less than or equal to B, then I can add or subtract the same number from both sides and it does not change the inequality. So A plus or minus C is less than B plus or minus C. If C is bigger than 0 and A is less than or equal to B, then AC is less than or equal to BC. So that says as long as that number is positive, I can multiply and divide both sides by the same number. However, if I multiply or divide by a negative number, then that's going to cause a change. It's going to cause AC to be greater than or equal to BC. So if we add or subtract by a negative number, we do need to flip the inequality. 2x plus 5 is less than 13. So when we subtract 5, 13 minus 5 is 8. Divide both sides by 2, and x is less than 4. And we can also graph this. So if here's 0, 4. Since we want less than 4, we're going to shade everything below 4. And since we're not actually including 4, we put a little open circle at 4. And this tells us we get really close to 4, but we don't actually touch 4. Negative 5t minus 6 is greater than or equal to 24. Just like an equation, we start by adding 6. That would give me 5t is greater than or equal to 30. And now I would divide by negative 5. However, multiplying or dividing by a negative number actually switches my inequality. So I have t is less than or equal to negative 6. This time, if we tried to graph this, we would still shade everything below since we want less than, but since we're actually including 6 this time, we put a closed dot, like this. Here's another one, slightly more complicated. We can start by distributing 9d plus 9 times 4 is 36 is less than 6d. 6 times 4 is 24, and then plus 3d. That gives me 9d plus 36 is less than 9d plus 24. When I subtract 9d from both sides to get the d's together, you'll notice it cancels on both sides and I'm left with 36 is less than 24. But that's impossible. So since that's impossible, this problem actually has no real solutions. Let's look at one more. Negative 4 minus 2 times x plus 1 greater than or equal to negative 2x minus 10. Distributing would give me minus 4 minus 2x minus 2 is greater than or equal to minus 2x minus 10. So this is negative 6 minus 2x greater than or equal to negative 2x minus 10. When I add 2x to try to get the x's together, this time I have negative 6 is greater than or equal to negative 10, which is always true no matter what. Negative 6 is bigger than negative 10. So this solution is actually all real numbers. Any number that you can think of is actually going to make this inequality true.